Hello everybody, my name is Dmitry and I'm CTO of Almalence, and what I would like to present you today is a solution to improve VR HMDs. VR is by no doubt its future, bright and shiny, but the current generation of VR displays are not able to immerse us completely in virtual reality. The main reason is image quality. Field of view is not optimal, resolution is too low, various aberrations are present. Field of view is no doubt will be improved. New displays with higher resolution are already being produced, but optical system is much more difficult to improve. And the problems of optical system will be even more apparent with coming displays of higher resolution. So why is that? The optical system cannot be improved much because it has to satisfy contradictory design requirements. The optics in VR display, in VR HMDs, should be small, lightweight, provide a good image quality over wide field of view, and have a large eye box. In Almalence, we have developed a software solution to pre-correct an image to be displayed in such a way that it negates completely the effects of optical aberrations produced by VR optical system. Whether it's a conventional lens like in Gear VR or Fresnel lens system as in HTC Vive. For our solution to work for a particular optical system, we have to profile it. This consists of capturing multiple special charts through VR optical system. We also need to know eye position to perfectly correct aberrations, because eye is also a part of optical system. So we are using eye tracking to locate eye pupil. By the way, we have a real-time demo running on HTC Vive. Now I will present some slides demonstrating why is it working and how it works. Let's assume you want to display an ideal image which looks like that through VR HMD. What you will actually see if you apply no corrections is more like that. In order to get better image, you have to apply brightness compensation to get even brightness across the field of view. You want to apply to geometry distortion to get straight lines looking straight, and you want to scale your red and blue channels relative to the green channel to get rid of later chromatic aberrations, which are seen as a color fringing. The final image will be more like that, which is almost perfect, except that at the corners it will still be a little blurry because there are other aberrations which are not corrected. Typical VR optical system consists of display, lens, very simple lens, and an eye. We should remember that eye is also a part of optical system. Let's see how lateral chromatic aberrations look like. Because of a simple plastic lens we have in HMD optics, it has a very high dispersion, and therefore it will produce lateral chromatic aberrations. And lateral chromatic aberrations manifest themselves as different color channels hitting different areas on your retina. And in the image it looks like that. On the left you see original image, middle column, how it looks through the VR lens without any correction applied, and on the right how it will look if proper correction is applied. So far so good. Now let's consider that every person's face is different, and we cannot guarantee that HMD will be in a perfect position for which VR optical system was designed. How lateral chromatic aberrations will look in this case? They still will be present, although they will be not symmetric anymore. Again, how it looks in the image. On the left you see original image, the second row is the second column is uncorrected image. Then after usual correction applied, you will see image like that, which still shows some fringing, simply because lateral chromatic aberrations are not symmetric anymore. And on the right column you see how our solution works. You can see it produces perfect image again. Now, besides lateral chromatic aberrations, there are also longitudinal chromatic aberrations, which manifest themselves as different color channels having focus at different distances. And how it looks in the image, you can see original image on the left, then how it looks through VR lens in the middle, you can see a lot of blur in blue channel, and on the right, how it looks after our correction is applied. You can see that it is not exactly as sharp as the original image, but it is much better than how it looks with conventional correction. Now, what if I is in the optimal position for the optical system, but you're not looking at the image center, rather you're looking towards the edge of the field of view? The image will look smeared, simply because with such a simple optical system, it is not possible to correct all the optical aberrations, such as astigmatism, spherical coma, or other higher order aberrations, and they will cause smearing. How it looks in the image: on the left is the original image, middle is how it looks through VR lens, whether you apply correction or do not apply conventional correction, because it is not able to correct this kind of aberrations. And on the right is our result. You can see it's much closer to original image.